Okay, chapter 4, here we go. So this one is just a one-pager. We're going to get through this today. No problem. All in one go. So adding and subtracting radicals. We just looked at multiplying and dividing. We figured that one out. Now we need to look at what does it look like to add and subtract radicals. This can be a little bit tricky to recognize the pattern at first. However, I am going to walk you through step by step and you'll be able to see what we can do with this. What will help you is to imagine what you would do with variables. If you remember what you can do with variables, like this, if you go 2x plus 3x, this equals 5x, right? You've got 2x's here, you got 3 of them, you combine them, you get 5x. Notice the x doesn't change, right? Nothing new happens to the x. We're just combining them. So that's similar with radicals. Instead of x's, we've now got root 5. So 2 root 5 plus 3 root 5's, you end up with 5 root 5's. Again, we're not touching the root 5. We're not changing anything with that. We are simply dealing with how many we have. So for something like this, you got 4 root 5 plus 3 root 5. The root 5 doesn't change. I simply add them. 7 root 5. That's it. I had 4 of them. I add 3 more. You end up with 7. Looking at the next one here. So 2 root 7 minus 4 root 7. Again, in your mind, if you are at all confused, you can pretend that you've got this. 2x minus 4x. And what would you do with this? It equals negative 2x. Okay, that you can do. Now, if I want to do it for real, it's the same thing. Just 2 minus 4 gives you minus 2. And instead of x, I've got root 7. So if you like that kind of pretend way, you can pretend it looks like this. You do not have to. However, that might help you in the in-between process and trying to understand what's going on here. Let's look at this one. So here, notice again, they're all root 2's. So they're all the same roots here. So I just combine numbers. Negative 8 plus 10 gives you positive 2. Minus 5 gives you negative 3 root 2. Again, no work to be shown, just that. Let's try the next example here. So notice here, these actually don't have the same roots. Sorry, this root sign shouldn't include the plus. However, when we simplify it, we might notice that you can actually combine these. So let's simplify as much as we can here. So this one I can take out a root 4 plus this one I can take out a root 9. Notice I'm going to be left with root 2's. So here I've got 2 root 2 plus 3 root 2. I can now combine those into 5 root 2. So sometimes those, they're hidden. You have a hidden combination between the two of them. So just try it. Same with here. So I got 3 root 4 times root 5. There we go. We're going to have root 5's in common. So 3 times square root 4, which is 2. So 6 root 5. Whoops, 5, not 6. Minus 6 root 5. And, oh, that's just 0. So that's that. Not too crazy. Let's try down here. Okay. So here we've got an issue. I can't simplify anything. I notice that I've got a root 5 here and a root 5 here and a root 7 and a root 7 here. So I can deal with the root 5's by themselves and I can deal with the root 7's by themselves. Again, you can pretend like each of these roots are a different variable. So you could pretend that we've got 4x minus 3y, because it's a different root, minus 2y plus 5x. This is what you can pretend. So if you pretend this, we can say that this is equal to 4x plus 5x, combining like terms, gives you 9x. Negative 3y minus another 2y gives you minus 5y. So this is what you can pretend. It's just different variables. Instead of variables, we got roots. If this is helpful, stick with this. Or you can just recognize root 5, that's a like term, the same root. So I can combine those, 9 root 5. Minus 3 root 7 minus another 2 root 7, you get minus 5 root 7. This is as simplified as you get. You cannot simplify the roots any further, so that is that. That's it. Let's try again with this next one here. So here you notice we're going to need to simplify. I can simplify this one and I can simplify this one. So we've got 2 root 4 times root 3. So here's where I'm going to combine with that one. Minus 3 root 2 plus 3 times root 4 times root 2 minus 5 root 3. So get rid of the square roots that I can here. 2 times 2 gives you 4 root 3 minus 3 root 2 plus 3 times 2 gives you 6 root 2 minus 5 root 3, and combine like terms. 4 root 3 minus 5 root 3 gives you minus 1 root 3. You don't have to put the 1. I like to put the 1. And then minus 3 root 2 plus 6 root 2 gives you plus 3 root 2. For those of you who like to, you can rearrange this through root 2 minus root 3. That looks a little bit nicer. But if you didn't, I'd still accept the other one. That's that. That's how you rearrange them. You can only combine like terms, and that's it. Like I've said before, I can continue to do this with cubes as well, cube roots. It's the exact same process. Instead of having a square root, it's a cube root. So here I've got the same root. I've got 2 cube root 2 minus 5 cube root 2. I can just pretend like the cube root of 2 is my variable, and I get minus 3 cube root of 2. Just combining the terms in front. Again, you can also simplify. So 2 cube root of 3 minus 3. I can take out 8 from here. So cube root of 8 times cube root of 3 plus 5 cube root 3. This gives me 2 cube root 3 minus 3 times 2, so minus 6 cube root 3 plus 5 cube root 3. 2 minus 6 is minus 4, plus 5 is 1, so the answer is cube root of 3. That is that. That is adding and subtracting. So you can only combine like terms, so making sure that you recognize what is like terms. You need to simplify each radical whenever you get the chance, and then combine all the terms. And there might be cases like this where you cannot combine them, and that's okay. So sometimes you'll have an answer that looks like that.